So today we're going over 5.3, trigonometric function of angles. Evaluate trigonometric function at any angle. So last time in 5.2, we was talking about the ratio, trigonometric ratios. Trigonometric ratios, I mean like angle, it is like acute angle, any angle between 0 and 90. But today, like I said last time, we're going to learn how to find or evaluate the trigonometric ratio for any angle, last time I just graphed the important angles like the 0 angle, 90 degree, 180, 270, 3000, 360. And also I graphed the angle for like 30 and 60 and also 45. I start talk about how we can evaluate trigonometric function at any angle. I start talk about the sign of the trigonometric function, and I graph the Cartesian plane, the fourth quadrant. I mean, like I said, like some functions has a positive sign in some location. For example, for the first one here, in the first quadrant here, all function should be positive. All function must be positive. Like I mean, the sign for any angle in this position must be positive. Here, all functions must be positive. In the second quadrant, the only function must be positive is the sine function. Sine angle. If the angle it's in the second quadrant, the sine function must be positive, and the other functions, it is negative. For the third quadrant, the only function must be positive is the tan function, the tan of the theta. And for the fourth quadrant, the only function must be positive is the cosine function. Cosine function. I mean, the cosine and the reciprocal of the cosine is the secant function. So I put this in one word: all students take calculus. All students take calculus. To just remind you how we can remember this. All students take calculus. I mean, all function here must be positive. Sine function positive. Tan function is the positive function in the third quadrant, and the cosine function is the positive function in the fourth quadrant. Now, the reference angle, I said I give the definition of the reference angle. The reference angle, I said last time, it's like acute angle. Acute angle between the terminal side and the x-axis. It is the angle between the terminal side and the x-axis. Again, it is acute angle. Let me just write the definition. Is acute angle. Acute angle is any angle between 0 and 90 degree. Here formed by the terminal side, terminal side and of theta and the x-axis. Here I get a question: are we going to get the grade before final? Yes. The final is very soon. Final, I think next week. This is from next week, I think, the final. Yeah. So here, the reference angle, number 2, it is an acute angle between the x-axis, and acute angle between the terminal side and the x-axis. For the first one is here, this one. This one. Just please, for the final, focus in this section. We will get this section and the next section. You will see a lot of questions in the final. Okay, so the reference angle is acute angle formed by the terminal side of theta and the x-axis. I gave like a small table last time. The table is like this. This is the reference angle. This is the angle in the first quadrant. This is angle in the second quadrant, angle in the third quadrant, angle in the fourth quadrant. The angle here is pi over 3, pi over 3. I don't know if it's fit. Let me check. Let me open it in the next slide. Is better. This table will help you a lot to find the reference angle. Again, here is the 1, 2, and 3, 4. This table, you should memorize it because it will help you a lot to find the reference angle. Here is the reference angle. Angle in the first quadrant, angle in the second quadrant, angle in the third quadrant, and the fourth one. Pi over 3. 2 pi over 3. 4 pi over 3. And 5 pi over 3. All of them have the same reference angle is pi over 3. All of them. To check that, just graph the angle in the Cartesian plane, xy, and check what is the acute angle between the x-axis and the terminal side. You will see all of them have the same acute angle. Is not pi over 3, so degree is not pi over 3, 30 degree. No, it's 60 degree. This is the 60 degree. This is equal 60 degree. Pi over 3 is 60 degree. How I know? Just put in instead of pi 180 over 3, 180 over 3 is 60. Okay. The second one. The second one is pi over 6 and 5 pi over 6 in the second quadrant. In the third quadrant, it is 7 pi over 6. And in the fourth quadrant, the angle should be 11 pi over 6. All this angle have the same reference angle is pi over 6. The reference angle is the acute angle between the terminal side and the x-axis. Again, this is 60 degree, 30 degree. This is 30 degree. Why? 180 over 6 is 30. And the last angle is pi over 4. Pi over 4 is 45. This is in this first quadrant. In the second quadrant, it is 3 pi over 4. In the third quadrant is 5 pi over 4. And the last one is 7 pi over 4 in the fourth quadrant. All of them have the same reference angle is pi over 6, pi over 4. Pi over 4 is 45 degree. It is equal 45 degree. Again, you have to memorize this table, will help you a lot to find the reference angle. Here's the first one, and this one, and this one. Okay, my question, the exam question, asked to find the value. So the example now, find sine of 7 pi over 6. Like this is the question. Can someone, okay. The question is, find sine 7 pi over 6. So first of all, to know what's the value or to solve something like this, you should graph the angle. You have to know where is the angle location, where is the location of this angle. So all the time, all the time, my initial side, it is the positive x-axis, like this. All the time, my initial side is the positive x-axis, and my vertex is the 0 point here. Now, 7 pi over 6, if you want to graph this one, or if you would like to know in which quadrant, you have to ask yourself. Here, the first angle in the first quadrant, this point here, if you want to open the angle like this until here, this point, this angle is 90 degree or pi over 2. Okay, so this here, if the angle here is pi over 2. And pi over 2, if you want to change it, convert it to something over 6, you have to multiply both sides, the numerator and the denominator, by 3. Multiply this by 3, multiply this by 3, you will get 3 pi over 6. And 7 pi over 6 is greater than 3 pi over 6. So the angle must be greater than this. So suppose check if it's in the second quadrant. The second quadrant, if I want to open the angle from this point going like this point here, it is pi. And pi is actually pi over 1. And again, if you want to make it the denominator equal 6, you have to multiply both sides by 6. You're going to get 6 pi over 6. And 7 pi over 6 is still greater than this. 7 pi over 6 is greater than pi. So it's supposed to be in the fourth quadrant, or in the third quadrant or fourth quadrant. Again, if you want to open the angle again, like this, up to this point to check. This point actually is 3 pi over 2. You should to make the denominator 6. So you have to multiply both sides by 3. Multiply this by 3, you will get 9 pi over 6. And 9 pi over 6 is greater than 7 pi over 6. So the 7 pi over 6 is between 6 pi over 6 and 9 pi over 6. So the angle must be in the third quadrant. Is it clear what I said? The angle must be in the third quadrant, because 7 pi over 6 is between 6 pi over 6 and 9 pi over 6, between two angles. Again, this point is pi over 2. Pi over 2 is, we have to multiply the numerator and denominator by 3 to make the denominator equal 6, to compare it with this angle. This is 3 pi over 6, and 7 pi over 6 is still greater than 3 pi over 6. This point is pi, only pi, and pi actually is pi over 1. You have to multiply both sides by 6. You will get 6 pi over 6. And still 7 pi over 6 is greater than 6 pi over 6. This point here is 3 pi over 2. 3 pi over 2, you have to multiply the both sides by 3. You will get 9 pi over 6. The 9 pi over 6 is greater than 7 pi over 6. So this angle must be in the third quadrant. So it's supposed to be here. Here is my location for this angle. So the angle is supposed to be like this. This is theta. Now my acute angle is a point, is acute, my reference angle is acute angle. Acute angle from the x-axis and the terminal side. Here is the terminal side, and here is the x-axis. So this is my acute angle. This is the reference angle. So this is my reference angle. Or you can go back to the table. So let me write first of all the location for this angle. It's in the third quadrant. So the sine, number 1, sine of the sine function in the third quadrant. What is the sign? Is positive or negative? What's the sign of the sine function is in the third quadrant? Going back to the table, all function here is the sign only positive, here is the tan only positive. The sign in this quadrant is the sine function in this quadrant. What's the sign of this sign? Of sine here?
Negative.
It's negative. The sign of this, the sine function in the third quadrant must be negative. So here's the sign of sine function is negative. Why? Because in the third quadrant, the angle it's ended at the third quadrant. So the angle must have a sign negative. Now, second step, it's what's the reference angle? The reference angle equal what? Going back here, 7 pi over 6. So here is the 7 pi over 6. This is 7 pi over 6. It's in the third quadrant. So this is correct as we find it. We find it in the third quadrant. So 7 pi over 6 has a reference angle is, it's 7 pi over 6. Again, my angle, it is 7 pi over 6 in the third quadrant. So the reference angle, it's here, it is pi over 6. Pi over 6. So the reference angle is pi over 6. This is my reference angle. Now we can evaluate the value for the sine. So sine 7 pi over 6 equal negative. The negative come from here. Sine the pi over 6. Now what's the sine of pi over 6 from the table last time? What's the sine of pi over 6? Or you can ask yourself, what is the sine of 30 degree? What's the sine of 30 degree? Sine of 30 is, anyone check the table? Okay, let me remind you, the sine of 30 is 1/2. Yes, Victoria, correct. So here is minus 1/2. This is the final answer for this example. Minus sine pi over 6 is minus this minus sine of pi over 6. The sine of pi over 6 is 1/2. So the answer is minus 1/2. Any question for this example? No questions? Okay. What about the other students? So the sine of 7 pi over 6 is minus 1/2. You have to follow the steps. You will see a question like this in the final. Find sine 7 pi over 6, or find sine 5 pi over 6, or sine 5 pi over 4, for example. You have to follow the steps like here. Follow the steps. Yes, what's your question?
But where did the final answer come from? The -1/2?
Because you have to ask yourself, what is the sine of pi over 6? The sine pi over 6 from the table last time. Did you remember the table from last time? Sine of 30, sine of 60, sine.
30 is 1/2.
Yes, 1/2. And the minus, you see the minus in front of the
Yeah,
sign?
but there's no 30
We find
in
it here.
this situation.
Yeah, you can write like, you can write minus sine of 30.
Oh, the 360/6. Oh, that makes sense.
Yeah,
Oh, thank you.
because the minus Yeah, the minus come from the sign of the sine function, like I said before. And the reference angle come from this table. Here is the reference angle. This is the reference angle here. This is the reference angle.
Okay, wait. So if I'm being clear,
Yeah.
all we got to do is find if it's negative or positive,
Yes,
and
the
the reference
reference.
angle, and just solve it.
Yes, that's it. Two
So does
steps.
it mean that for example sine 8 pi over 6 is gonna have the same exact answer as this?
The 8 pi over 6.
Mm-hmm.
Oh yes, because the sign in the third quadrant for the sine function is negative.
Mm-hmm.
But 8 pi
Okay,
over
so it's
6 you have, but 8 pi over 6 does not have the same reference. The reference is not pi over 6. But this angle I give
so
you,
you don't
like
have
this angle,
the
yeah,
table.
these angles are special, you know. So I mean, like when I give you an example, I will give you one of this, the special one. I will not give you
Mm-hmm.
another one because the other one you have to use the
Okay.
calculator, and the calculator is not allowed.
Okay, got it. Thank you.
No problem. Another example. Find a cosine of 240 degree. Cosine of 240 degree. Okay, to find this, you have first of all graph to see the angle in which quadrant. First, second, third, fourth. So 240, so this is angle, like I said before, all the time, my initial side must be here, the positive x-axis. This is my initial side. All the time, my initial side here. Now, second step, you have to find where is this angle location. So as you see here, if you stop at this point is a 90 degree. 90 degree, the 240 is greater than 90 degree. This point here is 180 degree. And again, the 240 is greater than 180. And this angle here, if you wanna move like this, I mean, this angle, it's supposed to be 270. Okay. And again, if you move, turn around, this angle again is 360 degree. So the 240 is between 180 and 270. So the angle should be here, like this again. So the angle must be in the third quadrant. So this is the angle. Now you have to, like the sine, number one, the sine of the cosine function is, what's the cosine function has a sign here in the third quadrant? Go back.
Negative.
Yeah, exactly, negative. Because in this quadrant, the tan function, but just the only one is positive. Other function are negatives. The tan is the only one positive. So the cosine has a negative sign. This is the first step. Second step, you have to find the reference angle. The reference angle for 240, I did not give it to you in the table, but it is easy to find it. The reference angle is acute angle between the x-axis. This is my x-axis. Is acute angle between the x-axis and the terminal side. This is my terminal side. So it is here. So should be, the angle should be from this point to this point. This is my reference angle. No, Delian, this is the reference angle should be from 180 between, like, you cannot do 270 minus this because the angle is between the x-axis and the terminal side. Wherever you said 270 minus 240, it is between the y-axis and the terminal side. But my angle should be from the x-axis and the terminal side. So my terminal side here, the angle is 240, correct? And the angle here is 180. So the reference angle, the blue one, should be between 240 minus 180 is 240. It's here only, this to this. This is my reference angle. Is 240 minus 180. And what does that equal?
60.
60 degree. So the reference angle is 60. Now it's easy to find the value for the cosine function. So the cosine function now, cosine of 240 equal minus, like this, cosine of 60. Now you go back to the table. What's the cosine of 60? You should
One
take note.
half.
1/2. Okay, so minus 1/2. This is the answer. Any question for this example?
No.
No question. Okay, so another example. The example is find secant of minus pi over 4. What's the value? First of all, like I said before, you have to graph. So here is my Cartesian plane. This is my y-axis. This is my x-axis. Again, my terminal, my initial side must be positive x-axis. So it will be here. And the vertex is the 0, 0 point. That's the origin. Now minus pi over 4. How can I graph this angle? Did you remember in the beginning of this section when I said the minus means we have to move like clockwise or counterclockwise? Do you remember when I said counterclockwise and clockwise? So the minus here means we have to rotate like clockwise around. We have to move clockwise instead of counterclockwise. Here the positive means, look, the angle is counterclockwise. Counterclockwise must be moving the opposite of the clock. But here is the angle is negative. This is mean we have to like we have to rotate as clockwise like this. So this is my terminal side, like this. So this is angle here, it's minus pi over 4. Minus pi over 4. The angle here, it is minus pi, make it correct, pi over 4. So first of all, you have to ask about the sign. So number one, the sign. What's the sign of the secant? Sign of the secant. The secant, it's the reciprocal of the cosine function. So the sign of the secant is the same as the sign of the cosine. So in the fourth quadrant, in the fourth quadrant, the cosine is positive, right? The cosine function is positive in the fourth quadrant. This is mean also the secant is positive. So the secant here is positive also. The secant is positive in the fourth quadrant. Now step number 2, what's the reference angle? What's the reference angle? The reference angle is the acute angle between the x-axis, this is my x-axis, and the terminal side, this is my terminal side, the green one. So it would be from here to here. This is my acute angle or the reference angle. What's the value of the reference angle here? What's the reference angle? As you see here, the angle here, it's minus pi over 4. So the reference angle must be the positive of this one. Is pi over 4, positive. Is it clear? The positive pi over 4. So now we can solve it. It is easy to solve. So the secant, I can write here. I will solve it here. The secant of minus pi over 4 is equal 1 over cosine of minus pi over 4, and this is equal 1 over. Now what's the cosine here? It has a positive angle, a positive sign, so this is the positive, and the reference angle, it's pi over 4. The cosine of pi over 4, the positive. Now what's the cosine of pi over 4? What's the cosine of pi over 4?
Square root of 2 divided by 2.
Exactly, it's the square root of 2 divided by 2. So I get here answer 1 over square root of 2 divided by 2. And the answer for this, it is the reciprocal of the square root of 2 over 2 is 2 over the square root of 2. This is the final answer. Any question?
Yes, why did you use reciprocal?
Because actually 1 over square root of 2 over 2 is equal 1 divided by square root of 2 over 2. And as we learned from the beginning of the book, we have to write it 1 times the reciprocal of this. What's the reciprocal of this? 2 over the square root of 2. And 2 times 1 is 2. And here actually over 1. 1 times square root of 2 is square root of 2. Okay? Mayasha, can you please explain how you get the angle? Which angle? The answer here, 2 over square root of 2. Acute angle, the acute angle, this one. Okay, so my angle here, the opposite side, it's minus pi over 4. This is minus 4 pi over 4. So the acute angle is the distance from this point to this point. So I know from here to here, it's minus pi over 4. So the acute angle here must be pi over 4, the absolute value of this. The absolute value of this, pi over 4. So the secant now of minus pi over 4 equal 1 over cosine minus pi over 4. The secant is the opposite of the cosine. And the cosine has a positive angle in the fourth quadrant. And the reference angle is pi over 4, the positive. And this is equal 1 over square root of 2 over 2 from the table. Now I use this one, explain it here. 1 over square root of 2 over 2 equal 2 over square root of 2. Why? Because 1 over the square root of 2 over 2 actually equal 1 divided by square root of 2 over 2. And as we learned from the beginning of the book, it's equal 1 times the reciprocal of this. We change the device to multiplication over multiply by 2 over square root of 2, and 1 times 2 is 2, 1 times the square root of 2 is 2. Is it clear?
So wait, the final answer is 2 over radical 2.
Yes. Why it's in the fourth quadrant? It is in the fourth quadrant because the angle here is negative pi over 4. So in the beginning of this chapter, I said when you see the angle is negative, this is mean we have to move clockwise. So I move clockwise pi over 4. Here it is positive, the angle is positive. This is mean we have to move counterclockwise. This is counterclockwise 240. In the previous example, it is positive 7 pi over 6. So counterclockwise 7 pi over 6. But here negative pi over 4. Negative means clockwise. Okay, so it's fine now. It's clear. Okay, I have another example. This is like an exercise for you. You have to do it because they will help you to understand the material more. The question is, the exercise is, find the value of the sine of 16 pi over 3. Find the sine of 16 pi over 3. 16 pi over 3. Okay, now I'm moving to the fundamental identities. So here, fundamental identities. Fundamental identities. The first one you have to show, this is like just a review. First one is the cosecant function, number one. Cosecant, here cosecant of any angle supposed to be 1 over sine. The cosecant is the reciprocal of the sine, 1 over sine, 1 over the sine of the angle. For the second one is the secant of the angle equal 1 over cosine, always 1 over cosine, 1 over cosine of the angle. For the third one, it is the tan. The tan function is 1 over, as we learn, the tan is 1 over what? Tan. I mean, like cosecant, secant, the tan is the sine over the cosine. The sine over the cosine, sine function over the cosine function. Here, tan of angle, theta. The tan of theta. So here, the tan of theta equal the sine over the cosine. And number 4, the cotan angle, it is 1 over 10. 1 over 10. Here, 1 over 10 of the angle theta. And also the cotan, number 5, again, cotan of the theta is the reciprocal of this, the cosine over the sine. Cosine over sine. Here, cosine of the angle, cosine of theta over the sine of theta. This is called the fundamental identities. And we have another identities is the Pythagorean identities. They are like this.
Wait, why do we have two cotangents?
The cotan, the first cotan is 1 over 10. And the second cotan is the reciprocal of the 10, is cosine over sine. Or you can write as like this. I will show you. So I know the cotan of theta is 1 over 10, right? The 10 equals sine over cosine, sine of theta over cosine of theta. 1 over sine over cosine, and this is equal 1 divided by sine over cosine, and this is equal 1 times the reciprocal of this, cosine of theta over sine of theta. And cosine times 1 is cosine of theta over sine of theta. That's why the cotan, the second one, is cosine over sine. Okay? Sine over cosine is the 10. Clear?
Yeah.
Okay. So that's why the second cotan is cosine over sine, or the reciprocal of this 10, cosine over sine. Now, the Pythagorean identities, we have another identities, is the Pythagorean. Pythagorean identities. First one is number 1. We should know the sine square of theta plus cosine square of theta equal 1. Number 2, if you like dividing this, all the equation here, the sine square plus cosine square equal 1. If you're dividing all this equation by sine square, you will get 1 plus, like if you divide everything by sine square, you will get 1 over cosine square over sine square. Cosine square over sine is cotan square of theta over 1 over sine square. 1 over sine square is cosecant square of theta. And the third one, if you're dividing everything by cosine square. So sine square over cosine square is 10. 10 square theta plus cosine square over cosine square is 1. And 1 over cosine square is secant square. So all of them are the Pythagorean identity. First one is sine square plus cosine square equal 1. 1 plus cotan square of theta equals cosecant square. 10 plus 1 equal secant square. You should memorize this identities. Now I have important example. The example is evaluate a trigonometric function. function if the tan theta if the tan of theta, number one, if the tan of this theta is equal 2/3, and also theta, here I should say, and this theta here, it is in the third quadrant, is in quadrant quadrant 3, 1, 2, 3. Find, the question is find cosine of theta. How I can find the cosine of theta? The tan of theta is 3/2, and theta is in the third quadrant. The question is find cosine of theta. How can I find the cosine of theta? Okay, to do these things, you should to graph a right triangle like this. This is the first step. You have to graph a right triangle like this. And this right triangle, and the tan of this is 2/3. What is the mean of tan? Tan of angle equal the opposite over what? Adjacent, right? Exactly. Opposite over edge. The opposite over edge equal 2/3. So the distance from here to here is 2. And the distance from here to here is 3, because this is the opposite and this is the adjacent. Now I have to ask myself, what's the value for the hypotenuse? Because I need to find the question of the cosine. What's the hypotenuse? By using the Pythagorean theorem, said 3 square plus 2 square equal x square, or x square equal 2 square plus 3 square. So x square equal 2 square equal 3 square. So x square equal 9, equal 4 plus 9. And this is equal what? 13. So the x value, take the square root of both sides. X equal what? Square root of 13. So the value of x is the square root of 13. Any question? How I know? By using the Pythagorean theorem. Now my question, my theta, it's in the third quadrant. The third quadrant, what's the sign of the cosine function? What's the sign of the cosine function in the third quadrant?
Negative.
Negative, correct. So number one, the sign of the cosine function is negative. Why? Because theta is in the third quadrant. So the sign of cosine is negative. Now, second step, we have to find the cosine. The cosine of theta equal what? By using here the right triangle. Equal the adjacent over the hypotenuse, right? Over hypotenuse. So because we have negative here, so equal negative of the adjacent is 3 over the hypotenuse is the square root of 13. 3 over square root of 13. And this is my answer for the cosine function. Any question?
No, but can you go back for a second? The last
Yeah.
slide.
Here.
Thank you.
Professor, I have a question.
You're welcome.
Professor,
Yeah, what's your question?
what can you please go
Yes.
back? When do we use
Yes.
the identities?
So you use the identities when like the question told you find the cosecant of theta or cosecant, for example, like this. Look. Find secant minus pi over 4. You should to know the secant of minus pi over 4 equal 1 over cosine minus pi over 4. So because here the secant of theta equal 1 over cosine of theta. So for example, in the previous question, the secant of minus pi over 4 equal 1 over cosine pi minus pi over 4. And the same things for the tan of theta. If like you have, sometimes you will use it, like the tan of theta is sine over cosine. The cotangent of theta, you have to know it's 1 over tan, or it's the reciprocal of the tan, 1 over the cosine over sine. Like they have some like using, like sometimes you will use this also, the sine square plus cosine square equal 1. If, for example, I give you the value of sine and I ask you for the value of the cosine, so you should use this properties or this identity. You have to square the sine square plus cosine square equal 1. So this is from here I can get 1. I can get the cosine of the angle equal 1 minus the sine square of theta under the square root.
Okay, thank you.
Okay. Can you please tell us which chapter we should focus for the final? So the final will be cumulative. I mean, the final will cover all materials from the first section to the last section. I prefer if you want to study like hard, focus in the like for chapter 3, for example, also chapter 4, the logarithm. Also focus in these things here, this chapter. But like make all your focus in the 8 chapters. I mean, like this chapter and chapter 4, chapter 3, like this. How many questions? Maybe from 9 to 17 questions. Okay. Any question for this example?
Yeah.
Yeah. What's your
So
question?
I know we did step 1, which is finding the sine, but why didn't we have to find the reference angle again?
We don't have to find the reference angle here in this step. We use just the triangle.
Oh, okay.
We don't
So
have to
for the
use the
side
reference angle.
just use the side.
Yeah, here, yeah, numbers here without two. I mean, like here, just use the triangle direct. We don't have to find the reference. Yeah, this question is also very important. Like every final has similar question to this. Here we don't have to find the reference angle. Here we should use the triangle, the right triangle. This is the difference about example like this and the previous examples. Here we have to find the sine, number one. Second things, we have to use the right triangle to find the answer.
One more question.
Yes.
So let's say in the finals you ask us to like a question like this. Do we have to like draw out the
Right triangle? Yes.
The like, do we have to show how we found that is negative, or can we just
No, just you can tell me, because the theta is in the third quadrant. The cosine function in the third quadrant, it has a negative sign, like this. You don't have to graph or to show.
Okay.
Just write like this. The sign of the cosine is negative. Why? Because the angle, it's in the third quadrant. So because the angle, it's in the third quadrant, the cosine function is negative in the third quadrant. So I can understand what you said. You don't have to graph or to show me like, you don't have to write the Cartesian plane.
Yeah, that was
No,
okay.
no, you don't. And you should use the right triangle to find the value. So the cosine of theta, because the cosine negative, so you have to write cosine of theta equal negative. You see the negative here, the adjacent over the hypotenuse, and this is equal the negative. The adjacent is 3, and the hypotenuse is the square root of 13. Square root of 13, I got it from the Pythagorean identity. I use the Pythagorean, I use the Pythagorean theorem for the value of x. Me too. So okay, so here I have another example. So if so, my example now. So I have another example. Example number 2. The question is, if the secant of the angle equal to the question, and also and theta in the quadrant 4, in the quadrant in quadrant 4, like this. This is 4. Find the five trigonometric function of theta. Okay, how I can find the 5 trigonometric function of theta? So first of all, they give me secant of theta equal to. They give me the value of secant of theta equal to, and they give me the angle. It's in the fourth quadrant. Okay, the angle, it's in the fourth quadrant. The angle in the fourth quadrant will help me to find the sine of each trigonometric function. And they give me here the secant of theta equal to. So let me start solving this question. So here secant of theta equal to, the secant is the reciprocal of cosine function. So I can say here, I can set here cosine of theta is the reciprocal of secant 1/2. Again, secant function is the reciprocal of cosine, and the cosine is the reciprocal of secant. So the secant of theta equal to, the cosine of theta equal 1/2. Now graph what? A right triangle like this. So my angle is here. This is theta. Again, the cosine equal, the cosine function equal the adjacent over hypotenuse. So the adjacent is, so the distance, this is mean the distance from this point to this point, suppose is 1. And the distance from this point to this point, the hypotenuse, is 2. Now I have to find the value of x. I have to find the value of x. How can I find the value of x? By using the Pythagorean theorem. The Pythagorean theorem said the hypotenuse square equal 1 square plus x square. So 2 square equal the x square plus 1 square. The 2 square is 4. equal x squared plus 1. Now, subtract the 1 from both sides, -1, -1, you will get 3 equal x squared. Take the square root for both sides, you will get square root of 3 equal x. So the value of x equal the square root of 3. So now I can easily find the other trigonometric functions. Okay, first of all, number 1, the sine of theta. So first of all, the theta, it's in the quadrant 4. The sine function will be positive or negative in the fourth quadrant?
Negative.
Negative, correct. Now you can find the sine from the right triangle, right? The sine equal the opposite over the hypotenuse, square root of 3 over 2. Now, the reciprocal of sine is cosecant, right? Cosecant function. The reciprocal of this is -2 over square root of 3. Now, number 3, function number 3, the tan function, the tan of theta. The tan in the fourth quadrant, is it positive or negative?
Negative. Only cosine is positive.
Yes, exactly. Only cosine is positive, so it will be negative. Correct. The tan of theta is negative, so it is the opposite over the hypotenuse, or the opposite over the adjacent. The opposite is the square root of 3 over 1. So the answer is minus square root of 3 only. Number 4.
Professor, didn't you say that like what tangent was positive since it's in the fourth quadrant?
You don't have to tell me, but you have to focus. You have to know it is negative in the fourth quadrant. Like, don't get mistake, both negative and it is positive, for example. You have to focus the angle, it's in the fourth quadrant, so the tan is negative. The tan is, okay, now the reciprocal of the tan is the cotan. The cotan, it's the reciprocal of this. So it is negative 1 over square root of 3. The last function is, we have the secant, we have that's it, I think. The last thing is here, we have the secant and the cosine. So the secant here. The secant is given in the example, secant of theta. I mean, let me start from the cosine of theta, because it's in the fourth quadrant, so the cosine is positive. And the cosine is 1 over 2. Adjacent over the hypotenuse, 1 over 2. This is number 5. Number 6 is the reciprocal of the cosine. The reciprocal of the cosine is the secant theta, and again is positive. The reciprocal of 1 over 2 is 2. That's it. So we find the 6 trigonometric functions of theta. That's it.
Wait, how did we find square root of 3 again? I don't know why I'm kind of lost today.
What's that?
X, how do we find X again?
How you find the x again? Okay, by using the Pythagorean theorem. The Pythagorean theorem said the hypotenuse square equal this side square plus this side square plus x square. So 2 square equal x square plus 1 square. Now the 2 square is 4 equal x square plus 1. Subtract the 1 from both sides, you will get 3 equal x square. Take the square root for both sides, you get square root of 3 equal x. So the value of x is the square root of 3.
Oh, I get it now. Thank you.
No problem.
Because I didn't even see that.
Yeah, it's fine. That's it for this. Now we have the last things in this section is the area of the triangles. So we have like just one formula. The formula is easy and direct. It's not much hard. Here the area areas of triangles.
I'm so sorry to ask you to go back, but why
Yeah.
do we have some of them in positive and negative?
Yes.
I understand because it's in quadrant, the fourth quadrant, but what about the last two?
Yeah, okay. For the last two here, the angle it's in the fourth quadrant. So in the fourth quadrant, the cosine is positive, and also the reciprocal of cosine is positive. The reciprocal of cosine is secant, so it's positive. That's why the cosine angle, the angle it's in the fourth quadrant. So the cosine must be positive, and also the reciprocal of the cosine is secant. The secant must be also positive.
So wait, when it specifies that an angle is in a certain quadrant, does that mean the rest is gonna be the opposite of the sine? Does that make sense?
Yes.
Oh, okay.
Yes.
Okay.
Like, or you should to ask exactly. The rest is negative. Like we know the cosine is positive, and the rest of them is negative.
Okay.
Understand?
So
The
let's say,
cosine and the rest. Yeah.
okay, let's say it
Yes.
was
The
like,
cosine and the rest. Yeah. Go ahead.
okay, I'm saying let's say it was in the third quadrant. Does that mean the last two are gonna be negative and the rest will be positive?
Yes. The 10 will be positive, and the rest is negative. The 10,
Okay.
the 10 will be positive, and the reciprocal of 10 is positive. The reciprocal of 10 is cotan, is positive, and the rest are negative. Like the sine is negative, the cosine is negative. Understand?
Okay.
The same things for the second quadrant. The sine is positive, and the rest are negative. The cosine is negative. The tan is negative. The reciprocal of sine is cosecant, will be positive. The sine and the reciprocal are positive, and the rest, all of them negative. That's why here the cosine positive, the secant is positive, and the other, all of them negative.
Got it.
Area of angles. Okay, the area of angles. So we have like just one formula here. It's not that much hard. The area, we denote it by script A of triangle. With length A and B, with include angles, theta is. So the area of the script A, so this is my A, of triangle with the length A and a B. Okay, with include angles, the angle here should be like theta is. So here is theta. So it is like this. Script A equal A, I mean 1/2 for the A times A times B times the sine of theta. This angle is the theta between A and B. So I will give you example to show you how we can applying for this formula. The example is find the area for triangles. This is my triangle here. This is 10 centimeter, and this is 3 centimeter, and the angle here is 120. The question is find the area of this triangle. So the area for triangle, the formula is script A equal 1/2 times the value of A, the length of A, the length of B, and the sine function of the angle. First of all, what's the length of A? Suppose this is my A, suppose this is my B. And just plugging inside the formula. So script of A equal what? 1/2 times 10 times 3 times the sine of the angle between both of them. The angle is 120. So just I have like one things here, I have to fix it. The sine of 120. So first of all, 120 in which quadrant? We have to find the value of sine 120. My goal now to find the sine of 120. How I can find it? I need two things. I need to find the sine, and I need to find the reference. The reference is like this, reference angle. Now, the sine in the second, this is 120. In which quadrant? 120, it's above of 90 degree and less than 180 degree. So if I want to like graph the Cartesian plane like this, my initial side is the positive x-axis. And the angle here, 120. So this angle is 90. And this angle here is 180. So this angle 120 should be exactly, Victoria. It is in the second quadrant. It must be in the second quadrant. So it's supposed to be like this. This is my angle. So this is my angle. Clear? This angle, it is 120 degree. Correct. 120 degree. So first of all, what's the sign of the sine function in the second quadrant?
Positive.
Positive, correct. So it will be positive. Second question, what's the reference angle of 120? The reference angle, it's acute angle. The acute angle between what? The terminal side and the x-axis. The x-axis is here. So this is my reference angle. What's the value of the reference angle?
Are you gonna say 180 minus 120?
Correct. It is 180 minus 120. So my reference angle, it is 180. It is this minus the black one, 120. What's the value? It's 60. Now it's easy to find the sine of 120. So the sine of 120 equal positive, the sign here, of sine of the reference angle 60. What's the sine of 60?
Square root of 2 divided by 2.
What's the sine of 60? Is 1/2?
Square. Wait, no. I say it's square root of 3 divided by 2.
Yes, exactly. Square root of 3 over 2. Correct. So the sine of 120 is the positive of the square root of 3 over 2. Now you can find the area here. You can find the area. So go back to the question now. Here is done for the angle. The angle side for the angle is done. Now we're going to the question. So the area I'm going to the next slide. Equal 1/2 times 10 times 3 times 3 times the sine of 120. The sine of 120 is positive square root of 3 over 2. Square root of 3 over 2. Now we can solve it this. Here I get 1 times 10, 30, and 10 times 3 is 30. 30 square root of 3 over 2 times 2 is 4. I can simplify this by dividing both sides by 2. I will get 15 square root of 3 over 2. This is my answer. Any question? Any question for this example? So this is the area. That's it for this section. We're done by this section. Just you have to know the area, and the last part of this section is the area of the tree for the triangles. This area of triangles, they use the sine of the angle. That's why you have to know how to use, how to evaluate the sine of the angle. Now let's go to the next slide. The next slide, it's the inverse function of a trigonometric function, the inverse. .4 inverse trigonometry functions and right triangles. So what does that mean? So you should know like this. The inverse for the sine, cosine, and tan. This is mean the inverse for the sine function and the cosine function and the tan function. We're going to learn how to do or to find the inverse for this function. So first of all, you should know the sine inverse of x equal y. This is exactly the same as if you take the sine for both sides, you will get x equal or sine of y. This is equal the sine. If you take the sine for both sides, you will get here sine of y equal x only. For the second example, for the second function, cosine inverse of x equal y. So this is mean if you take the cosine for both sides, you will get cosine of y equal x. Now for the third one is the tan inverse of x equal y. If you're taking the tan for both sides, you will get tan of y equal x. But we have only like this function, I cannot take the tan for both sides for any function. So that's why I'm going to restrict the domain for the function. So I'm going to restrict the domain for the function. So I can say here, so I can make a table, small table. Here we have the function. And here we have the domain for the function. And here we have also the range. That's why we're going to restrict the domain for the function, because the function is not one-to-one function. The sine function, the cosine function, the tan function, all of them not one-to-one function. That's why I cannot find the inverse for them. But if I just restrict the domain for the sine, the cosine, the tan function, I mean, like I can make the domain smaller than the original one, so I can find the inverse for these functions. So the first function is the sine. So the sine inverse of theta, the domain should be the value from -1 to 1, and the range here must be from -π/2 to the π/2. For the second function is the cosine inverse. The domain must be from -1 to 1, and the range must be from 0 to pi only. The last one is the tan inverse. The function must be the domain is from, I mean, like from -infinity to infinity is r, and the range must be the open parentheses from -π/2 to π/2. This is the domain, and the range must be, we use it for this function to find the value for any inverse for these functions. This table is very important table. They will help me a lot to solve and to find the inverse for any value. So let me start by giving example. So the example one here, or before the example, let me explain like small things here. So what does that mean? Here I mean like small example for this. So I mean like sine inverse, I mean sine of π/6 is the same as what? What's the sine of π/6? It's 1/2, right? It's sine of 30. Sine of 30 is 1/2. So you should to know this is convert to sine inverse of 1/2 equal π/6. Okay, second one is the cosine of π/3. What's the cosine of π/3? Cosine of 60 is 1/2, right? This is if we want to convert it. I mean here to inverse. If I wanna like convert to inverse, this is equivalent to cosine inverse of 1/2. Cosine inverse of 1/2 equal π/6, π/3. This is what I mean of this example. Okay, now let's give example and explain how I can use the table here. How I can use the table exactly. This table, you have to memorize it. So the example is, like this. Evaluate the inverse for the trigonometric function for each of the following. Number one, find the sine inverse of square root of 3 over 2. Okay, let me do the first one. My question is, find the square root of the sine inverse of the square root of 3 over 2. So you have to ask yourself, first one, is the square root of 3 belong to the domain? What is the domain of the sine inverse? The domain of the
Negative
sine
1 to
inverse.
1.
Exactly. Is it this number belong to this interval from -1 to 1? Is the square root of 3 over 2 belong to -1 to 1? This is your first question for this example. Square root of 3 over 2 is like a value close to 1/2. Is it the 1/2 belong to this interval? What's the answer? The
Can you
1/2.
repeat the question?
Is this value belong to this interval from -1 to 1? Is the square root of over 3, square root of 3 over 2 belong to the interval from -1 to 1? The answer is yes.
Wait, yes?
Yes. Why? Because the 1/2, this is like close to 1/2, right? And this interval is from -1 to 1, like -1 and -1/2 and 0 and like 1/2 and like 1 over yeah, 3 over 4 to 1. Like this is the interval. From -1 to 1 is from -1 to 1. -1, -1/2, 0, 1/2, 3 over 4, and 1. So the 1/2 is belongs to this interval. This is correct. So the answer is yes. So the answer is yes. Now,
Sorry,
this is the first
can I-
question.
Sorry, can you go back to the table? Like, I'm really.
Yeah, here's the table. Sine inverse, the domain must be from -1 to 1. The cosine inverse, the domain must be from -1 to 1. The tan inverse, the domain must be the R. The range is from -π/2 to π/2, 0 to pi, -π/2 to π/2, but here including the endpoint, here doesn't include. Now, so the answer is yes. Now you have to write like this: sine inverse of square root of 3 over 2 equal y. Take the sign for both sides. When I take the sign for this and take the sign for this, I will get what? The convert for this is sine of y equal square root of 3 over 2. Now you're looking for y. Here y should be to belong to the range. This y must be belong to the range. This is the range. Do you see the range? This is the range from -π/2 to π/2. Now my question is, what's the value if I plug it inside this function, the sine, they will give me square root of 3 over 2. So you should to go back to the table from last previous class. What's the value of y if I plug it here? They
It is
will give me,
5/2.
what is that? What's the angle? What's the angle if I plug it here? They will give me the square root of 3 over 2. And this angle must be belong to this interval. Sine of
The angle of pi over 2 is 90 degrees.
pi over 2, it's 90 degrees, yes. The sine of pi,
Pi
the
over
90
3.
degrees,
I think it's pi over 3. Wait.
if it's 30, the sine of 30, what is the answer? Sine of 30 is 1/2, right? So it's not the answer. Sine of 30, the 30 degree, it is pi over 6.
I want to say
So
2
it's not
pi
the
over-
answer. What is the answer?
2 pi over 6. Does that make sense?
2 pi over 6. What about the sine of 60? Sine of 60.
Isn't that square root of 3 over 2?
Yes. So the y here must be 60. So 60, if you want to convert it to the radian, it is pi over 3. And the pi over 3 is belong to this interval. Pi over 3 is belonging to this interval. So y equal pi over 3. And it is belong to the interval minus pi over 2 to pi over 2. Okay, any question for this? I will give you another example. I will give another example. So my example is find, second one is find the cosine inverse, number 2, cosine inverse of minus 1/2. Cosine inverse of minus 1/2. Who will do this one? First of all, is minus 1/2 belong to the domain? So to solve this one, you have to check, is the minus 1/2 belong to the domain? What is the domain of the cosine inverse?
-1 to 1.
Correct. From -1 to 1. -1 to 1. Is the minus 1/2 belong to this interval? Is it between -1 and 1?
Yes.
The answer, yes. So it is correct. So it's fine. Now we can find the inverse. If the answer is yes, so you can find the inverse. If the answer is no, this does not have a value. You have to write, it doesn't have a value, no answer. Now, so we have to continue. So the cosine inverse of minus 1/2 equal what? Y. Now this is mean, take the cosine for the both function, take the cosine for both functions, so I will get cosine of y equal minus 1/2, such that this y must belong to the range. What's the range? From 0 to pi. 0 to pi. Now, what's the value here if I plug it inside? What the value if I put it here? They give me answer minus 1/2.
I want to say negative pi over 3.
Pi over 3 negative. But the angle must be from 0 to pi without negative. Minus pi over 3 does not belong to this interval. From 0 to pi. You need an angle. So I can set the reference angle. What's the reference angle before you look into the minus? I mean, like the reference angle, you have to hide the minus. Like if you want to solve something like that, if you want to solve something like this, hide the minus like this, hide it, and ask yourself, what's the value if I plug it here? They give me 1/2.
60.
60, cosine of 60. Yes, it's pi over 3, right?
Yeah.
Cosine of 60. So the reference angle is pi over 3. Now, because the angle is between 0 and pi, so I'm looking for the angle, the reference angle is pi over 6, right? The reference angle is pi over 6, but because we have a minus here, so the minus, this is mean the angle must be in the second quadrant. So go back to the table of the reference. This is the table of the reference here. So the angle pi over 6 is the reference angle, so it's supposed to be in the second quadrant. Second quadrant is between 0, is like the second quadrant, because the second quadrant, the cosine will be negative. So the angle must be 5 pi over 6. No, hold on. First of all, what's the cosine of pi over 6? This is 30. Ah, you said 60, right? So here is over 3. The angle here over 3. Pi over 3 is this angle here is 60 degree. The cosine of 60 is 1/2 positive. But I'm looking for angle, it is negative. Because it's negative, so the cosine in the second quadrant is negative. The cosine in the second quadrant is negative. So I'm looking for the angle y. This is the reference y. I need the y in the second quadrant of pi over 3. So go back to the table again. Here is the pi over 3. Second quadrant, it's 2 pi over 3. So the answer is 2 pi over 3. So here 2 pi over 3. So this is my answer.
Wait, how did you get
Any
2 pi
question
over 3?
for this exam?
Yes, can you please show again?
Because
Yeah.
yeah, the reference angle, yeah, I mean, like for reference angle, you have to hide the minus here. Hide the minus. You have to ask yourself, cosine of angle equal 1/2. What's this angle? The angle is 60 degree or pi over 3. Now remove this box, you will see the minus. The minus means the cosine should be minus in the second quadrant. I mean, like the reference angle, it's pi over 3. Go back to the table and look for the second angle, for the like the angle in the second quadrant. Here is the table. This is pi over 6, the reference angle. You see this column is the pi over 3, this column for the reference. So the pi over 3, we have like this angle, it's in the first quadrant, such that the first quadrant or the function positive. In the second quadrant, the cosine will be negative, and this angle is between 0 and pi. So the 2 pi over 3 is the answer for pi over 3, because the reference angle is pi over 3 and the angle in the second quadrant is 2 pi over 3. So
Okay,
here the
thank
answer,
you.
yeah, the answer here y must be 2 pi over 3. Any question now?
I have a question.
So I'm going to give the last example before. Yeah, what's your question?
So why did you add the 2
Go ahead.
again?
Why I add the 2?
Mm-hmm.
Which 2 exactly?
The pi, it was supposed to be pi over 3, the reference angle, but then you added 2 pi over 3.
Okay, again, look, the angle here is negative, right?
Yeah.
The negative, the cosine has this angle here, must be between 0 and pi. 0 and pi. 0 and pi means the angle from this point to this point, like this. This is from 0 to pi. This is pi. This is 0. So in the first quadrant, the angle is not here. It's not in the first quadrant. Why? Because we have negative. You see the negative? The negative
Yeah.
means the angle must be in the second quadrant here. The angle must be here in this angle, in this quadrant. In this quadrant, if you go back to the table and you're looking for the angle has reference pi over 3 in the second quadrant, it will be 2 pi over 3. Go back to the table. Here is the table. This is angle here. Here is the reference angle is pi over 3. And I'm looking for the angle in second quadrant, has a reference pi over 3. It is 2 pi over 3. That's why the answer for my question is 2 pi over 3.
Oh, that makes sense. Okay, got
Okay.
it. Thank you.
So here the angle is y equal, not y reference, y is equal to pi over 3. The last example before we leave. The example is number 3. The tan inverse of 1 equal the tan inverse of 1. So you have to ask yourself, again, is the 1 belong to the interval of the domain? What's the domain? Are real numbers. Is the 1 belong to the real numbers? The answer is clear, yes. It's not hard. Yes, the 1 is belong to the real numbers. Okay, second question. Tan inverse of 1 equal y. Now take the tan for both sides. Tan of this y equal 1, such that this y must belong to the range. The range is from minus pi over 2 to pi over 2. Open parentheses, from minus pi over 2 to pi over 2. I mean, for this, if you want to graph the Cartesian plane like this, my angle must be from this point, this is pi over 2, to this pi over 2. This is my angle, must be in this quadrant. Quadrant 1 and quadrant number 4. Now the tan of y equal 1. What's the value of y? What the value if I plug it here, they give me 1.
It would have to be pi over 4.
Pi over 4, correct. If I plug the pi over 4 here, they will give me 1. Also, if I plug an angle here in this side, they will give me also 1. Why? Because the tan here positive. All student take calculus. No, here is not positive. Only the cosine. This is correct. So we have only one angle, y equal pi over 4. That's it. And pi over 4 is belong to the minus pi over 2 and pi over 2. Yes, because pi over 4 is here. This is the angle, pi over 4. Is it clear now? Okay, we're going to stop up to here for today, and I will see you I will see you Tuesday. Have a good day.
All right, see you Tuesday.
See you Tuesday.